could sit closer? No, no es posible. All right. Okay, lesson 3. We do have. Start today 40. Start today 40, please. Yeah. All right, lesson 3. Have that open. Continuing a bit with our geometry review, perimeter and circumference. What do we mean when we talk about perimeter? Perimeter, anybody? Anybody? Yes?
Space outside of the shape.
Not space. We don't want to say space for perimeter.
Adding up all the numbers.
Oh, what numbers?
On the sides. And
yeah, so what are those numbers representing? The what of the sides?
the length.
The length of the sides, right. Perimeter is the length or distance around a shape. It's always the distance. We want to know if you were going to walk around the shape, how far would you have to walk? Or if you were going to build a fence around the shape, how long would the fence have to be? Perimeter comes from Greek peri, which means around, and metron, which means measure. It's the measurement around, just like it says. All right, now generally speaking, when we've got something that has straight sides, as we were saying, Isaiah, how do we find the perimeter of something that has straight sides? We have something shaped like this, and say, we know what the lengths of the sides are. How are we going to find the perimeter of this? We're going to add them all together. When you're doing this with the perimeter, I recommend that you find a point to start at and do it just like you're going around the shape and add them up in order. So this one, say we're going to start here. So we're going to do 6 plus 5 is 11, plus 4 is 15, plus 3 is 18, plus 2 is 20, plus 8 is 28. We get a total of 28 units as our perimeter. Sometimes it's a little more complicated. When might our perimeter be a little bit more complicated to find? So if we just have straight sides, if this were a triangle or a quadrilateral or a pentagon or hexagon, any of those, you just add up the sides. Where might it become more complicated?
Sure.
Right, if we have something, a special word that we use for the perimeter of a circle, what is that? It starts with a C?
Circumference.
The circumference. Okay, from Latin, circum meaning around, and ferret meaning bring. So the bringing around. Circumference is just the perimeter of a circle. Only used for circles. And how do we find the circumference of a circle? Yep.
Radius and diameter.
Which one of those do you want to use?
Radius.
The radius. How are we going to find the circumference of the circle using radius? Ashley?
Radius times pi, the second pi. Or no, yeah, times 2.
Be careful, times what?
Times 2.
Times 2, right. So there are 2 ways we can do it. 2 pi r or pi times diameter. Now when we talk about the radius or the diameter of a circle, as a refresher, what are those? The radius or the diameter of a circle? What's the radius of a circle?
Half of it.
Half of what?
Half of the half of the diameter.
It's half the diameter. How can we define the radius though? The radius goes from where to where?
One side here.
That's the diameter. Diameter goes all the way across.
To the middle. Goes to the middle.
Right, the radius is half of that. So this is radius, and this whole thing is diameter. Diameter, notice it's got that meter, like in perimeter, is from dia, which is Greek for through, and metron, meaning measure. The diameter is the measurement through. The radius is half the diameter. It goes from the center to the edge. The definition of a circle is it's all the points that are the same distance from one other point. At any point on this circle, the radius is the same. The distance to the center is always the same. That's the definition of a circle. And so the radius and the diameter, by definition, the radius is half the diameter. So notice these are the same. Saying 2 times pi times the radius and saying pi times the diameter are the same. Because either we're taking the diameter multiplying by pi, or we're taking the radius times 2, which is the same as the diameter, and multiplying by pi. Now what is this number pi? As a quick refresher. What is pi?
3.14.
It's approximately equal to 3.1415926535897 yada yada yada. It goes on. How long does it go on for?
Did you just make that up?
Yeah, it goes on forever. It doesn't repeat, doesn't have any pattern to it. It's a special type of number that we're going to talk about in lesson 4. Sometimes we also use 22/7. That's fairly close to it. It's not exactly. And pi is this special number that helps us work with circles. Pi, if you look at your packet there at the top of page 11, pi is the relationship between the diameter and the circumference of a circle, always. It's pi. And we can see this here, the diameter of that circle. We could take 3 of them and fit them all the way around, and then there's a little bit left over. And that leftover part is the 0.1415926, etc. This is true for every single circle. It's just a fact about the way that circles work. That the relationship between the diameter and the circumference is always pi. Don't get this confused. Don't get these formulas confused with what other circle formula. What's the other circle formula that you probably know that it's really easy to get these confused with?
Pi r squared.
Pi r squared, which is what?
Area.
The area of a circle. Yeah, we're not dealing with that yet. We will have that this year. Don't get these mixed up. The difference between radius squared and 2 times the radius is a very large one. If your radius is 3, for example, 2 times 3 is 6, but 3 squared is 9. Those are different formulas. Don't get them mixed up. Even though this one has a 2 in it, it's not really a 2, it's a squared. Okay, so don't get those mixed up, please. Pretty please. Okay. Similarly, so we can find the circumference if we're given the radius or the diameter. Similarly, if we're given the circumference, we can find the diameter. So for example, let's say that we have a circle where the circumference, that's a really lopsided circle, that's okay, is 24 meters. And I want to know what the diameter is. What's the diameter of the circle? How am I going to find the diameter of this circle? I know what the circumference is. How can I find the diameter? Ashton. Divided by pi. Why does that work? Why does that work? What's the relation? Yeah, go ahead.
Because to get circumference, you could multiply pi times the diameter.
Right. Remember that formula for circumference that connects circumference and diameter is circumference equals pi times diameter. Well, we know that the circumference is 24, and we're trying to get diameter by itself. When I write pi diameter like this, what's connecting those two, the pi and the diameter? Multiplication means pi times diameter. So how am I going to get this diameter by itself? Divided by pi. So I divide by pi over here, that undoes that, and then I divide this by pi. For the purposes of this class, you can leave pi in your answers. In fact, I would request that you do. Don't go and calculate it all out by hand using 3.14. It's just going to take a lot of time, and you're more likely to make a mistake in your arithmetic. So for a problem like this, you can just write the diameter as 24 over pi. What am I missing? 24 over pi, what, dollars?
Oh, units.
Pounds? What unit?
Oh, meters.
Meters. And since it's diameter, we always know it's got to be something of distance. So if I write dollars, that's obviously not right, because dollars is not a measurement of distance. If I write gallons, that's also not a measurement of distance. It's got to be a distance measurement. All right. And if it were the radius, we'd do the same thing, except then we'd be using this formula. So you can go either way between them. What I recommend is, now with this one it was really easy, right? We know that we have to divide the circumference by pi to get the diameter. But to make sure that you don't make a mistake, you can always rewrite the formula and then plug in your numbers. Circumference equals pi times diameter. Well, we know the circumference is 24, so we can write that instead of the c, and that'll help us find the diameter. We know, to get this diameter by itself, we're going to need to divide by pi. Just like if we were trying to find the circumference of a circle, we would plug it into that formula using either the diameter or the radius. So use those formulas, write them out. I recommend you just write them out in the form that you learn them, then plug in the numbers, and then it should be pretty clear what you need to do to get your answer. Okay, questions about circles, circumference, diameter, radius? Okay, great. Let's talk a little bit more about perimeter because this book likes to use sort of complicated perimeter problems. What if I have a shape that looks like this? How am I going to find the perimeter of it? Now, of course, you'll be given some measurements, like maybe we'll say 5 inches, 7 inches, and we'll draw a little something here to indicate that it's a semicircle up there. So how am I going to find the perimeter of this? Yep.
7 plus 7 plus 5
And where'd you get that other 7?
on the other side.
Right. So this shape, anytime you have a complicated shape, try to break it up into things we know how to deal with. This shape is a combination of what two things?
Square.
Rectangle and a circle. And this rectangle, because this side on the left is 7, the one on the right also has to be 7. So we're going to have 7 plus 7 plus 5. Okay. So there's how many inches there? 7 plus 7 plus 5?
Oh,
19. Now, but we're not done yet because there's still we haven't gone all the way around the shape yet. What do we still have left?
that's half it.
We still have half a circle. How are we going to find the perimeter of this part here, this curved part?
You can only do a unit right there. The number.
You use 5 as the diameter, and then do everything like it was a circle and divide by 2.
Right, so this is a semicircle, it's half a circle. So to find the perimeter of it, we're going to treat it like it's a circle and then divide it by 2. We've got half the perimeter of a circle. Now, as you pointed out, we need to have some measurement of the circle. I don't have anything written here. But, as you noted, this is a rectangle. So not only is this left side 7 and this right side 7, since the bottom is 5 inches, this top here is also 5 inches. Now that's not part of our perimeter because it's on the inside. We're only measuring the distance around the outside. But it is the diameter here of this semicircle. So to find the circumference of that semicircle, what are we going to do?
Multiply by 5.
Right, we're going to do 5 times pi, and then what are we going to have to do? Divide it by 2. Okay. And then we add these together. Now, there isn't an elegant way to write these. You're just going to have to write as 19 plus. You could write 5 over 2 pi. You could write 5 pi over 2. Either one of those is fine. Inches. There's your answer. The 19 coming from these 3 straight sides, which are easy to add up, and then that semicircle there, we treat it like a circle. And yes, be careful because this book will do things like that where they won't explicitly give you the diameter or the radius or whatever of this of the semicircle. You have to figure it out from the rest of the shape.
Wait, so we shouldn't use like we shouldn't do like 5 times pi and then actually divide by 2.
You should not calculate that out. No, leave pi in there. Don't use 22 over 7. Don't use 3.14159265535, etc. Obviously, you can do that if you really want to, but it's going to take a lot of time. It's not really the focus of this class. That's an arithmetic problem at that point. And we're going to have plenty of arithmetic to deal with anyway in this class, and it's going to take time, and it's easy enough to make mistakes. Now, in this particular case, I would probably use 22 over 7 because we've already got a fraction, 5 over 2 pi, so I'd probably use 22 over 7. But yeah, don't just leave pi there. Okay. All right. You could write 2.5 pi. 5 divided by 2, you could do that. But you can write 5 over 2, or you can write 2 and 1/2. That one's fine. Okay, let's do one more example from here, and then we're going to start talking a little bit about lesson 4 before I give you guys time to work on homework. So let's just do, we're going to do one of the practice problems from page 13. So you look at page 13, we're going to do practice problem C, right there at the top of the page. Can I raise perimeter and circumference?
Yeah.
All right. Okay, so we've got this funky shape. It looks like this. Let's see if I can draw it moderately well. They tell us some of the measurements: 2, 2, 4, 5, 12, 5. Now, what information do they give us? Don't just look at the image. Also, we should read what it says there. So, volunteer, please read the little information they give us to the left of that image there. Go ahead.
Find the perimeter of the sheet. All angles are right angles. Dimensions are in cube.
Right, so 2 or 3 really important pieces of information there. 1, what are we looking for? What's the problem asking for? The perimeter. Okay. So go ahead and write this stuff down when you're doing your work so you don't lose track of it. What's the second important piece of information that we get about this figure? All the angles are?
Right angle.
Right angles. So it's going to be very useful. And the third piece of information is what?
Dimensions are in kilometers.
Right, so this 12 here is not $12, not 12 scoops of ice cream, it's what? 12 kilometers, all right. And these are all kilometers. But again, I would write that on one of them, so you know what you're dealing with. Okay, so we want to find the perimeter of this. So we should just find a point to start at and go around, right? So where are we going to start? Somebody pick a corner. Okay, so we're gonna start here and go around. Okay, so we're gonna have 12 plus what? 5 plus 2 plus
2.
Wait a minute. So we had 12. I have another color marker on me. I don't. Okay, so we did 12. We're going around. Then we do 5. Then 2. Then 2. Then. Okay, we've got a side here that we don't have a measurement for. And if we're looking ahead a bit, we see we've got another side that we don't have a measurement for. How am I supposed to find the perimeter of this if I don't have the measurements of all the sides? Yes?
For the bottom one, I did 12 minus 6. Because the 2 tops, like 2 and 4, because they're parallel to 12.
Right. Remember that they told us that all the angles are right angles, which means we can think of this as, instead of one big funky shape, we can think of it as 3 rectangles, since they're all right angles. Okay. The width of all 3 rectangles, if we're dividing into 3, the width of them all together is what? 12. Okay, well this one has a width of 2, this one has a width of 4, so what's the width of this guy?
6.
They've all got to add up to 12. We've already got 2 and 4, so we need 6 more to add up to 12. What about this guy here?
2.
How do we know?
Doesn't the same from the other side.
Because these are right angles, because this is a right angle, the height of this line on this end and the height of it on this end are the same. We also know that the top of this side and the top of this side are the same. Why do we know that the tops of those are the same height? What does the left side say? 5, and the right side says 5. So we know that this is 5 here. This has got to be 2 here. We can think of it also as this rectangle in here has a height of 3. If this whole thing is a height of 5 and that's 2, this must be 3. If it's got a height of 3 over here, it also has a height of 3 over here. And so since this guy has a total height of 5, we've got 2 left. Okay, now we have all the sides. We can keep going. So we have 12, 5, 2, 2 again. And you can go and like cross these out as you're going around, just so that you don't repeat any or miss any. Okay, what are we at next? 4. Go in order, please.
6.
Yeah.
I thought you already
6,
2.
2,
4.
4, 5. All right. What's a convenient way to add up a big long string of numbers like this?
Separate.
Separate them. So what would you do first?
2 plus 2.
2 plus 2, great. So we got 4. What else can we do?
5 plus 5.
Okay, we can add the 5 and 5 together. Yeah, but go ahead and cross things out as you do this. What else can we add together?
2 plus 6.
Oops, 5 plus 5 is 10. We already add the two 2's together.
2 plus 6.
2 plus 6, or maybe even easier, 6 plus 4. That'll also give us 10.
And 12.
And then 12 and 2 will give us 14, okay. 10 and 10 will give us 20. Okay, 4 plus 14 will give us 18. All right. 38 what?
Come on.
Kilometers. That is a long way to walk. How long is a kilometer, approximately? Or exactly? Okay. It's 1,000 meters by definition. How long is a meter? Approximately. A little over a yard. We have about 3.3 feet. Yard's 3 feet. What about in relation to a mile? How long is a kilometer in relation to a mile?
Similar.
I think, isn't it longer?
Kilometer is shorter than a mile. It's a
Oh,
little
yeah,
over
I was
half the
thinking
length of
about
a mile.
How it's more like if you look at like the conversion where like 1 mile blended being like more.
Right. So a 5K race is only 3.1 miles. The conversion, and we're going to do a lot of conversions this year, between kilometers and miles is 1.6 kilometers is 1 mile. So there's almost 2 kilometers, is close to 2 kilometers in every mile. Significantly shorter. All right. Questions, comments, concerns about any of that? Finding perimeter. Okay. Flip to page 14. We're going to go over the first probably the first 4 topics in lesson 4, and then I'll give you guys the rest of the period to start on the homework, which is probably so too. But lesson 4 is kind of long, so I want to get a start on it today. We're going to talk about some different types of numbers here. Can I erase this problem? Okay, you've got the diagram in your packet there. So, okay. First up, what is a number? Give me, we're going to talk about a number. Can someone give me an example number? Any number.
1.
1. What's a number? What's another number? A million is a number. 22 over 7 is a number. A number is this. But let me ask you another question. Have you ever seen a number? Have you ever seen 5?
Yes.
What does it look like?
Like, what do you mean, like drawn or like 5 or something?
Like 5. I don't mean like the thing that we write. I mean like 5. Have you ever seen 5?
Yeah,
What did it look like?
it's 5 things.
5 things. You saw 5 books, or $5, or 5, whatever. 5 things. We see things. Numbers are not the sort of things that we can see. They exist, but we can't see them. What we can see is we can see numerals. A number is, now they say an idea here. I don't really like that term for it. A number is an abstract thing. You could say it's a concept, but it's not something that we can see. It's invisible in a sort of philosophical sense. Not only can we not see it, we can't taste it, we can't hear it, we can't touch it, we can't smell it. Sort of like happiness. You can kind of feel happiness. But it's not the sort of thing that we really detect with our senses. Numbers are like that. Numerals are the things that we use to represent numbers in writing. in writing or in speech. So when I say 5, that sound is also not the thing 5, which we can't see or hear or touch. We could say 5, we could say 5, we could say quinque, we could say 20. Those are all different numerals, different symbols for 5. We could write it like this. 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 Let's see, what's another numeral for 5? That's Roman numerals and the Greek numerals. Let's see, I don't remember how to write the Chinese numeral for 5, I think. Anyway, I won't embarrass myself on YouTube. There are different numerals we could use to represent it. We could write it as 10 over 2. We could write it as 5.0. These are all different ways to write 5. Those are numerals. So keep this in mind. It's not an overly important distinction for the purposes of this class, but it is a good thing to remember that when we talk about numbers, we're talking about real things. They're not things that we can see. They're not the same as the symbols we write on the page, but they are real. There are lots of different types of numbers. Anyone want to name a type of number for me? Some different types of numbers. Not all numbers are the same.
Fractions.
Fractions. Fractions are a type of number. What about if we're talking about sheep? What are possible numbers of sheep that you might see? You might see 2 sheep. You might see how many? What's another number of sheep you might see?
7.
You might see 7 sheep. You might see. Could you see -3 sheep?
No, because that would.
No. Can you see 0 sheep?
No.
No. Can you see pi sheep? 3.141592653.
Yeah.
What?
If you cut one out.
Yeah, you might have to cut one up. Okay. Those numbers of sheep that we can see, these are our natural numbers or counting numbers. If you want a definition, which numbers are natural numbers or counting numbers? How can I talk about what numbers of sheep we can see? Yeah, starting at 1, because we can't see 0 sheep. So they're all positive. Positive integers. Integers are whole numbers. So 1, 2, 3, 4, and so on. If it's a number of things you can see, it's a natural number or a counting number. We've also got positive numbers. What's the definition of a positive number? 2 is a positive number. Is pi a positive number?
No.
What? What's the definition of a positive number?
Above.
It's greater than 0.
Oh,
And a negative number is what?
below 0.
Or less than 0. What about 0? Is 0 positive or negative?
No.
No, 0 just gets to hang out and do its own thing. So it's not either greater or less than itself. Okay. All the types of numbers that we're going to talk about today are all real numbers. A real number is something that could be an amount of something. The negative does count because you could, for assets. Have negative financial assets. You could have more debt than you have assets. You could have an irrational number. You could have a decimal. Obviously, you could have $50.39. Pi, that's a quantity that we can see. The numbers that are not real are what we call imaginary numbers. They're not going to be part of this class. If you know what they are, great. They're really weird and interesting. they'll briefly come up later in the year, but they're not something you need to know about. Okay. How do we represent a negative number?
Minus.
We put a negative sign in front of it. How do we designate a positive number? We could. Do we always?
No.
No, usually not. Negative sign. Positive sign or no sign. If there's no sign, we assume it's positive. Okay. Last thing, quickly. We can represent numbers on one of these. What is this? What kind of thing is this that we were talking about last week? It's a line. Look, it goes on forever this way and forever this way. That's what those things mean. What's right in the middle of this line? 0. And what do I have if I go this way on the line? What am I going to get? Positive numbers. 1, 2, 3, 4, 5, 6, 7, 8, etc. And if I go this way on the line, what am I going to get? I'm going to get negative numbers. Negative 1, negative 2, negative 3, negative 4. Now, any real number, every real number has a location on this line. So 1 is here, 0 is here. Remember, fractions also count as real numbers. 2.5 is here, halfway between 2 and 3. Pi has a place on this number line. Where is pi's place on the number line, roughly speaking? A little bit after 3. Right? It's between 3 and 4. It's bigger than 3, so it's got to be after 3. But it's not all the way to 4. There's a point on here which is the value is pi. All real numbers fit somewhere on this line. Positive numbers to the right, negative numbers to the left. So as we move in this direction on the line, are the numbers getting bigger or smaller?
Bigger.
Bigger, even when they're negative. Negative 3 is greater than negative 4. I would much rather owe you $3 than owe you $4. I guess saying much rather, like it's $1 difference. It's not that big. They're always getting bigger as you go this way, and they're always getting smaller as we go to the left. All right. Tomorrow we'll continue with 4. In the meantime, start working on problem set 3. I'll get you guys sheets if you don't have those. If you're watching virtually, check on the Jupyter Grades and ask me some questions.